Hello future coders, and welcome to Programming with Swift Playgrounds. Now in this video we're going to look at logical operators. Could you be a bit more specific please? Well, earlier when we used if statements they were great, but what if we could make them more powerful? You see, in code we have an operator which is a symbol which represents an action. So below equals plus ampersand ampersand. What does this mean? Let's take a closer look. A logical operator is a type of operator that can be used to make your conditional code more specific. So basically what we're saying is we've got three options or three operators, and they're called and, or not. And we use these symbols, double ampersand, double pipe, and the exclamation mark to represent these three options. The logical AND operator, or double ampersand, allows us to run the code only if all the conditions are true. So for example, if you like ice cream and the flavor is strawberry, that's when you'll eat it. Otherwise, you won't go near it. So here you can see we've got if is blocked, which means that the byte character cannot move forward because there's a wall, and you're on a gem, then click the gem and then you have to turn around. So both conditions must be true in order to execute or run the code in the body. Now we've got a logical OR operator, or the double pipe symbol. Now this code will run if at least one condition is true. So if dinner is either pizza or pasta, I'll eat it. Otherwise, I think I'll pass. So here, if we are on a gem or on a switch, then do a dance. Byte will also dance if both conditions are true as well, but only one has to be true. The final logical operator is called NOT, or the exclamation mark. And what this does is it changes the conditions to the opposite. So for example, if you're on a gem and it's true, if you go not on gem, this will make it false. For example, you can say, if the phone rings, I'll pick it up. Or you can say, if the phone not ring, or it doesn't ring, I won't pick it up. It just makes it the opposite. So here you can see we've got the if is blocked, you can't go anywhere, but if it is not blocked, then you can continue, or in this case, fly away. So, with this in mind, let's go ahead and learn about all these operators and start coding. This challenge here is called using the NOT operator, where we need to adjust our path when there's no gem on a tile. So the key to this challenge is you want to run the code a few times to understand the trick. Let me go ahead and change the number from 4 down to 1 and run the code. And what you'll see is that the stairs is going to change position. Let's run it again. There you go. It's changed position to the third tile. Now it's back at the first tile. And now it's at the second tile. So we need to use a NOT operator to basically decide when to go down the stairs. The first thing we want to do is move forward, but then we want to use the NOT operator to determine when byte is not on a gem. And when byte is not on a gem, you can see it's empty. That is when we want to turn left and collect the gem at the end of the stairs. So let's give this a go by saying move forward if. Now, the best way to start is say if is on gem. We'd say if we're on a gem, let's collect it. Otherwise, else, we could turn left and go down the stairs. However, a better way to do this is to say if we are not, so the exclamation mark, if not is on gem, what we want to do is not collect it, but we want to turn left. We then want to move forward 2 times. Then we want to collect the gem. Then we want to turn around by turning left 2 times. Then we'll move forward 2 times back to the center. And then we'll turn left 1 more time. But we can put down below, else we want to just collect the gem, because the else statement means that we actually are on a gem. So up top, this is what happens when we are not on a gem, and this is when we are on a gem. So let's go ahead and step through this code to see if it works. So we're stepping in, turning left because we're not on a gem. We're going forward, collecting, turning backwards, moving forward, turning left. There we go. Now, we want to go ahead and change the for loop to repeat 4 times. So now let's run the code normally and see if it works. So moving forward, we collect the gem. We're not on a gem, so now we go down the stairs, collect it, and then make our way back. Then when we move forward, we test. Are we not on a gem? Well, yes, we are actually, therefore collect it. And the same for the last one. And hooray, we've done it. We've used the logical not operator to change the condition so that we could walk down the stairs when we are not on a gem. Great stuff. Let's move on to the next challenge. This challenge is called the spiral of not, and they are getting harder as well. But no problems, because I'll help get you through. Now, let's go ahead and first of all run this code to see if the puzzle changes. Look at that. The position of the last switch changes. See how it changes there? And see how it changes there. So, how do you solve this? Well, let's first of all look at the code that's been given. It's a for loop going from 1 to 13. Why is 13 there? Do you want to have a guess? Well, if you count the steps, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's 13 steps. Let's change the puzzle again by running the code and count the steps again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's always 13 steps to go to the final destination. That is why it's in a for loop. So the secret to this puzzle here is that we have a new condition, and the condition is called is blocked. What this means is that if you move forward and you keep moving forward at the very end here, well, it's blocked. So if it's blocked, you actually want to turn left and go down here. Then you walk forward, and then it's a dead end. It's blocked. What do? You turn left. You keep moving forward, and then guess what? Another dead end. In which case, we have to turn left. So whenever we reach the end, we always have to turn left. So we can use this to our advantage. So let's go ahead and say, if is blocked, we want to turn left. So we know that. But if it is not blocked, let's change this. If it's not blocked, let's move forward. Else, we can then turn left. So let's try this. Let's go step through my code. Now, are we blocked? No, move forward. Are we blocked? No, move forward. Are we blocked? No, move forward. And keep continuing. See how simple this is? Now, are we blocked? Yes, we are. Jump down to the else and turn left. Now, are we blocked? No, let's continue to move forward. And this pattern repeats. So let's speed this up a bit. And look at that. So we haven't quite reached the end after 13 steps. So what can we do? Well, every time we turn left, it will be very helpful if we also move forward. Look at that. So now let's try this out. Look at that. We've actually reached the final square. Now, what we can do is that when we reach the final tile, we can then toggle our switch. So let's give this another go. Look at that. Excellent stuff, future coders. We use the logical not operator with the condition is blocked. So you'll always know when your character is not blocked that you can continue moving forward. And this is a neat trick which we'll use in future challenges. Okay, let's jump on to our next challenge. This challenge here is called checking this and that. We're going to use the AND operator to combine two conditions to adjust our path. Now, the secret here is that we have a new condition and it's called is blocked left. So basically, if it's true, meaning if we cannot turn left because there's a wall, then what we want to do is turn right. You can see here we've got a wall here, here, and down here. Now, there's a bit of a trick here because if we look at the end, there's a wall, so we want to turn right, go up the stairs, and toggle the switch, and then come back down. And we want to do the same for the other parts towards the end. However, we also have a wall near the beginning, but we don't want to do anything because the switch is already toggled on. So now that we know this, let's go ahead and see what we need to do. First of all, we can see we've got a loop going from 1 to 7. Do you know why the 7 is there? It's because we've got 1, 2, 3, 4, 5, 6, 7 tiles to go through. So the best way to approach this is to work backwards, in fact. At the end, we know that if there's a wall on the left, so if blocked left is true, then we want to not only collect the gem, but we want to turn right, go up the stairs, and then toggle the switch. So let's code for the end part first. Let's say if is blocked left and is on gem, then what we want to do is first collect the gem, then we want to turn right, move forward 2 times, toggle the switch, turn left, and then move forward 2 times again, and then turn right. And that'll get us back on the main path. So let's go ahead and test this first to see if we can collect the gems and toggle the switches on the rock area at the end. Let's run the code. There we go, collect the gem, turn right, go up the stairs, toggle the switch, and then come back down. Okay, so we know the code works for the is blocked left, but we've still got 3 gems to go. So how do we solve that? Well, we need to use more conditions. You'll notice that these 3 gems, there's nothing on the left. So why don't we say else if we're on a gem, so is on gem, and now there's actually nothing on the left, so nothing is blocking the left. So why do we say is not blocking on the left? So exclamation mark, the not, is blocked left. Then all we want to do is collect the gem. Let's try that. I'll run it through a bit faster. There we go, and that worked. Now, the reason why I did is blocked left first before is not blocked left, because sometimes it's a bit tricky to understand the negative of something. So doing the positive or the is blocked left first can make it easier to understand. But we could have reversed the order of the code and put this at the beginning and then this part here at the end as well. But either way, it works. So let's now move on to the next challenge. This challenge here is called checking this or that, where we're going to use the logical OR operator to combine two conditions, and the code will run when at least one of them is true. Now, how do we start? Well, we want to search for patterns in the puzzle. You can see that we've got a wall here and over here, and also on the other side. We've got some portals as well, and our loop has 12 steps. For 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 steps to get to our gem. Now, we want to keep moving forward until we hit a block in front of us or a block to the left, because notice how we're always going to be turning right. If we move forward here and we've got a block, we need to turn right. Here, if we can't move to the left, then we want to turn right. And then out here, again, if we've got a block to our left, we want to turn right. If we've got a block in front of us, we want to turn right. So the key is to identify or see the pattern that keep on moving forward unless you've got an obstacle in front of you or on the left of you. So with that in mind, let's go if and is blocked or is blocked left, then what we want to do is actually turn right. Because imagine we're here and we're blocked in front, then we want to turn right. And then if we're here and we're blocked to the left, then we want to turn right. Otherwise, let's just keep moving forward. Now let's give this a quick test to see if it works. And I'm going to change the 12. Let's reduce this down to, say, to 4. And let's step through the code. Here we go. Are we blocked? No. Let's move forward. Are we blocked? Yes. Let's turn right. Now, are we blocked? So we are blocked. What happens is that when we turn right, we go through the loop again, and we're still blocked on our left. So what this means is after we turn right, we need to move forward in order to go into this space here. So let's run this one more time. Here we go. We're not blocked at all, so let's move forward. We're blocked, so we turn right, and then we move forward. Are we blocked at all? No, let's move forward. Are we blocked on the left? Yes, we are. Let's turn right and move forward. Okay, so we've made some progress. So why don't we continue increasing the 4 to, say, 8 and see what happens. Let's run this a little faster. Okay, we're getting closer now. So let's change this to 12. and run it again. Wow, we've made it to the tile with the gem. You can probably guess now that the last step is to go and collect the gem. But the way we solved this was we broke down the challenge into smaller pieces, and we started off just going 4 steps and checking that is there anything blocking us from in front or from the left, because if there is, we want to turn right. So let's go ahead and run this and see if we can complete the puzzle. Excellent work, future coders. So we've used the logical OR to help us achieve our goal. If you're still a little confused, go ahead and try this puzzle again and reducing the for loop and then stepping through the code one step at a time. Otherwise, let's move on to our next challenge. Okay, this last challenge here of the section is called the logical labyrinth, and this one looks a little tricky. Now, as always, we want to take a minute to look and try to find some patterns. So pause the video and see if you can find patterns on your own first. Okay, did you find any patterns? One pattern that I can see here is every time we're on a closed switch and a gem, we want to go downstairs to collect the other gem. Over here, it's the same situation. We're on a gem and a closed switch, so move to the side and also collect the gem. That's one pattern. The other pattern is that when I go forward and something blocking me from in front, I want to turn on the switch and then turn right. Same down here. If there's something blocking from the left, then I want to go and turn on the switch and turn right. So let's break this down one step at a time. Let's go and solve for this first section here, where I want to say if is on gem, so if I'm on a gem and is on closed switch, what do we want to do? Well, we want to collect the gem and toggle the switch. But we also want to go and turn right, move forward 2 times, collect the gem, turn around, which is 2 turn lefts, and then move forward 2 times to get back up to the top, and then turn right. So we're back on the main path. So let's give this a go, and we'll reduce the count down to, say, 2. And let's step through the code. There we go. Toggle the switch. Turn left. I don't actually want to turn left. Let me stop this. I want to turn right, so I got the direction wrong. There's nothing wrong with making a mistake. That's how we learn. So let's go ahead and turn right this time, and we'll restart the code. Are we on a gem and a closed switch? Yes, we are. So let's now turn right, move forward. We'll collect the gem, turn around by doing 2 left turns, and then going back onto the main path. Brilliant. Now we want to solve the next piece of the challenge, which is when we meet an is closed switch and is blocking from the front, we want to toggle the switch. So let's go else if is on closed switch and is blocked. Let's go and toggle the switch. And then we want to turn which way? Left this time. So let's go ahead and test this out, and we'll increase our counter to maybe 4 this time, because it's 1, 2, 3, 4. And let's step through the code. Here we go, moving forward. The second condition is true, so we're going to toggle the switch and then turn left. And then we're going to move forward. Excellent work. So now you can guess that the next step is just a repeat repeat of our first step, because the is on gem and is close switch will trigger as true, we'll collect and toggle, and then we'll collect this gem as well. So let's increase the loop here to say 5, and we'll run this code a little quicker. Okay, there we go. Now, what do we want to do with the next tile? Well, we don't have a is blocked right. We only have a is blocked left. And the front is not blocked. So, how about we say that if we're on the next tile and we're not blocked in the front, we can toggle the switch. So what I mean by this is, let's have another else. If we can say is on close switch, and we can go is blocked, but we want this to be is not blocked, then let's toggle the switch and also turn left, like so. And let's see if this works. Let's go ahead and increase the count to 6 and run through the code. Look at that. Now we're set to walk in the right direction. Now, if you've been following along, you may have noticed that we're using this is blocked and condition, but guess what? We can delete this and simplify it, because the pattern is that on a closed switch, all we need to do is actually turn left. So if I go ahead and delete all of this, like so, let's retest this and see if it still works. Look at that. A closed switch allows us to turn left. Here we go. Close switch, turn left. So sometimes you can make the code more efficient and use less instructions to achieve the same goal. And that's what we did here. We recognized that we had two closed switches that after we turn them on, we actually want to turn left. Now, if we move forward, we want to say else if on gem, just collect it. So let me change the loop now to 8 and see if this works. Look at that, future coders. If you managed to complete this puzzle, then super congratulations, because it is a little bit challenging. I'll see you in the next one.